had the inequalities for one triangle, which basically wound up where you had where you were across from the largest angle was across from the longest side, the shortest angle was across from the shortest side, and so on and so on. Now that was pretty easy to know when you had one triangle. Now we switch it up to talk about when you have two triangles. And it's not that it's any more difficult or anything like that at all. It's actually very, very, very simple. It's just a matter of knowing exactly what you're looking at. And you can follow stuff in directions in the diagram. It's really easy. This thing's called what we call the hinge theorem. Okay? And real easy way of doing it, again, remember how we did our hands out and stuff? Do you guys agree that these staplers, for all intents and purposes, are the same? For all intents and purposes, they're the same size. Same sizes, they're all the same sizes. They're all pretty close, right? So, if I do this, do you agree that these two parts will stay congruent? These two parts will be congruent, and then these two parts will be congruent? So,
Stand up.
So, do you agree that you hold this up, this angle makes it, there's an imaginary segment here that creates a triangle, right? Okay? Do you agree that that's the same thing, right? So, looking at it, which angle, base angle between here, is larger? Correct. Which means what side length is going to be longer? This one. Even though these two are the same, between these two sides here are the same, this angle is bigger, which means this third side is bigger. That's what they call division work. See, that one So this is what we call the hinge theorem. The hinge theorem is super, super simple. And it's the idea that, sorry, I want to show that in terms of a picture first. It's the idea that when you have two triangles with two congruent side lengths, when you have two triangles with two congruent side lengths, which is completely, totally possible. It can happen all the time. The third side is always longer across from the bigger of the two angles. So whichever of these two angles is larger, remember we call it the included angle, the angle in between. So if this angle here is 60, this one is 95. If I say this is triangle A, B, C, X, Y, Z. What's going to be longer, BC or YZ? That's what that means. You've got two sides that are the same. The angle in between them determines which one of the third sides will be bigger. It's called the hinge theorem. It's really weirdly worded. Let's see if I can change this just a little bit. Let me change this up just a bit to clean this. Sorry. Root this real fast. Get the wording in here. Change So basically the idea is if two sides of one triangle are congruent to two sides of another, and the included angles are not congruent, the longer third side is across from the larger included angle. It's opposite the larger included angle. Again, fall back to the idea here, since angle X is greater than, I should use the symbol, than angle A, then YZ is greater than BC. That's all it means. That's all that means. Yes, ma'am. Oh, I didn't realize I said it. I didn't realize it was in there yet. It'll work eventually, right? Super simple to work with. It's again, this winds up being, when you look at a diagram, if there's certain information that you know, can you say what side's longer? That's really all this is allowing you to be able to do. It'll also allow us to find certain range of values if we're looking for certain side lengths or possible angle measurements, things like that. It's not a very complex process. It just sounds really, really weird. But if you remember the idea of using the staplers, these are the same things. You open up one further than another. This has got a longer length than this one does. That's all that means. It's that simple. Okay? It's just a lot of words for something that looks like that. And then obviously it works going backwards. Well, let's go to this one real quick. What's going to be the longest side length here? Just looking at those numbers. What does that be? LN. Why? Since angle M is 125, angle P is 78. Also notice that LM, OP are the same, MN and QP are the same. You've got your included angles between whichever angle is larger has the longer side length across from it. That's all it means. That means then you can say that LN is greater than QO. That's it. We're not trying to find those side lengths or anything. Not really. Second semester, you'll be able to find that side length. Second semester, you haven't learned how to do trig yet. It's easy. It's a formula. There's a formula in order to do it. There's a formula in order to do that. Okay. It's not. It's not. It's all straightforward. Okay. Again, same idea. Notice you've got two sides that are the same. You know that because of the tick marks. The included angle is given to you in both of them. One of them 70. What's the other? And why is it 90? It's the right angle, which means what side length is going to be larger, SK or YU? That's it. That's all we have to do here. It's that easy. All right. So it sounded like it was going to be awful. You guys go, just like you normally do. And you start to realize, oh, it also works going backwards. Okay, it works the same way going in reverse. Just like most theorems that we've had, we can say going backwards. If instead of this is 11, and this is 17, Which angle has to be bigger? It's all up to you guys. It's the same thing going back. So if you happen to have two sides congruent to two sides of another, same idea. And the third side, third sides are not congruent, then the included angle is larger across from the, oops, just got worded wrong. Included angle is larger across that's right, opposite, oops. Opposite the third side. That simple. Back and forth. Most definitions work in either direction in geometry. They're called biconditional statements. Two lines are perpendicular if and only if they create right angles. Two lines create right angles, then they are perpendicular. Same idea. It's the same thing moving forward and backwards. So if two sides of one triangle are congruent to two sides of another, the third sides are not congruent, then the larger included angle, oh, I've said it backwards. The larger included angle is opposite the longer third side. Sorry about that. Stupid medicine. Thanks. It's opposite the larger. I think I said that out loud, but I wrote it backwards. Like I said, I haven't been this in years. This is such an anomaly for me. I haven't had to go to the doctor for 3-4 years. I haven't needed to. I used to go pretty regularly for allergy medicine, but my allergy medicine became over the counter. So why should I go pay the doctor and then pay for a prescription when I can buy it at Costco for a third of the cost? Yeah, why would that? Costco. I like to go to Costco in grades. And then no matter what, you walk out the door, it's $200. I think that's some pretty good deals on stuff. I will say that. Actually, I found a dress shirt where there were ones for about $6. Okay, take it. You find some pretty good stuff in this. All right. So let's look at this how it does start to get a little weird. Here's how this can get weird. And it seems like it's odd, but what happens is it's the same procedure every time. What they ask us here for is, what are the range of possible values for x? Find the upper and find the lower value of x. Remember how we did that the other day when you were given two side lengths of a triangle, find the third? We would add them and we subtract them, figure out what possible values it could have been. This is kind of the same idea, but we're dealing with angles now. So I'll give you a second to draw that up, and then I'll walk you through how this works. Like I said, it looks really, really weird, but it's very easy. Okay. Now, this value here, they put the tick marks in the middle on that segment US. That's not always going to be given to you. It's going to ask you sometimes to kind of figure out where do you have a reflexive side. Can you mark something in a diagram? That kind of thing. And this one being the first example, I thought it would be a good idea to throw one in there for you guys. So let's see, we've got the two triangles. We've got RUS, and then we have SUT. RU and TU are congruent. SU is the shared reflexive side, so there's your two sets of congruent sides. That means the angles in between them is the 60-degree angle and that 5x minus 20. Now, such a nice guy, isn't he? Looking out for. Which of those two angles has to be bigger? The 60 or the 5x minus 20? Why does the 60 have to be bigger? Correct. Everybody see that? Because 15 is bigger than 10. So that means that 60 is the larger of the two angles, which means that 5x minus 20 has to be smaller than what? 60. Yep. It means that 5x minus 20 has to be smaller than 60. Let's write it down. Okay. So you treat it the same way like you would. What do you have to do first? Add. So you get 5x is less than 80. And what do you, oh, sorry. I'm not sure where you got that either. Divide that out, and you're going to get what? 16. So that means the upper boundary means x has to be smaller than 16. What do you think the lower boundary has to be? Greater than what? Where do you see a 120-degree angle? Can never assume. He's making an ass out of you and me, and there's no ass in. What if it's 1/2?
1/2? Oh, I thought you were like 1 inch.
Now bigger than 0. Exactly. The lower boundaries on these things always have to be greater than 0. So the lower limit means that this part, this 5x minus 20, has to be greater than 0. Because you can't have an angle that's smaller than 0. But it can't be 0. That's why it's not greater than or equal to. It has to be larger than 0. So what we do is we solve that inequality. Add 20. Divide by 5. So your range of values, x has to be bigger than 4, but smaller than 16. X is bigger than 4, but smaller than 16. See how that same way we write it out like we did with the possible side lengths? We do the same thing. But now we're talking about possible range of values for an angle. That means if x is 5, this triangle could work if x was 5, 6, 7, 8, 9, 10, any number between 4 and 16. These two, this figure could work. Right? That's because of how the math works. Right? Yes, ma'am. No. Nope. Because if you think about it, we can't have an angle value that's equal to 0. It's got to be greater than 0. Does that make sense? That's what we're doing. These boundary problems are super easy. We know that this angle has to be bigger than this angle because this side is bigger than this side. That's the upper limit. It's got to be smaller than it because that's what it says. The lower limit, well, that just means it has to be bigger than 0. You do the same thing. It's super easy. Like I said, it looks really weird, but in fact, it's pretty simple, isn't it? Let's try it over. Same idea. Let's find the possible range of values for x. First of all, what angle has to be bigger? The angle K or angle N? Angle N has to be larger. The reason that it has to be larger is because the side across from it is larger than the side across from the angle K. So what's the upper limit for angle K? What does it have to be smaller than? What does it have to be bigger than? 0. The 3x plus 18 has to be smaller than 90. At the same time, 3x plus 18 has to be greater than 0. You have an angle that's smaller than 0. That's why. Subtract 18. Divide by 3. Oops. Subtract 18. Divide by 3. Is it okay that you get a negative value for x? Yeah. Think about it. If you use negative 5 for x, what's 3 times negative 5? Negative 15. What's negative 15 plus 18? 3. So you still get a positive value. It's okay. That means your possible range of your range when you write it out as your final answer. What's 3 times negative 5? It has to be bigger than negative 6, but it has to be smaller than 24. When we ask for possible range of values, you always write your answers as what we call a compound inequality. You guys remember that?
Yes.
That's what that means. Let's put them together. It matches the idea of the other day when we were doing the what are the possible side lengths. Remember when we did that? We said if you had sides of 4, 9, and something, that means your sides have to be smaller than 13, but bigger than 5. Remember that? Add them, subtract them, same idea. But now we're just talking about range of values looking at angles. Yeah. Possible range of values. Possible range of values. It's really, like I said, it looks really weird for something that's pretty darn simple. Okay. Not bad? Don't die on it. Feel it. Good? Yeah. Do those. We're a little bit ahead of the other classes because we're not going to. So, give you guys a little bit of time to get it. I got a textbook up here. If you want to take a picture of it, please do. You've got to get 20-minute head start. I